Welcome back. In the previous video, we were talking about images of functions. In this video, we'll be talking about preimages of functions. Again, we're going to have a function that has domain capital X and codomain capital Y. We're going to focus on an element that's in capital Y. So let little y be an element of the codomain. We can define the preimage of y to be the set of all elements in X whose image is equal to little y. And we'll use this notation f to the minus 1 of y. So in mathematical terms, the preimage of y is equal to the set of all x in the domain such that f of x is equal to y. So a couple of notes about this notation. It's important to recognize that we're not saying that f to the minus 1 is the inverse of the function f. We're using this notation to say what are the possible elements that get sent to little y. Another thing that's different is that the image of an element is an element, but the preimage of an element is a set. It's a subset of the domain. And when you're reading the book, they call this the complete inverse image of little y. Just as we defined the image of a set, we can define the preimage of a set. Let's take a set that lives in the codomain, so let capital B be a subset of the codomain. The preimage of B under F is written again f to the minus 1 of B, and it's defined by the preimage of B under F is equal to the set of all elements in the domain where the image of that element lies in the set capital B. So in words, it's the set of all elements in capital X whose image are elements in B. The preimage of capital B is a subset of X. And in the book, they call this the inverse image of B. Let's talk about computing the preimage of a function. So to compute the preimage of an element, you need to find all the elements in the domain that have y as its image. And if you were computing the preimage of a set, you would do that for all elements of B. So let's do some examples. Let's say our function is defined by an arrow diagram. You have to figure out which elements point to y, or to elements of B. So if we're looking for the preimage of D, we see that there are two elements in the domain that have D as the image in the codomain. And so the preimage of D is C comma D, and that's a subset of the domain. What about when we're looking for the preimage of A? In this situation, there are no elements that map to A, and so the preimage of A is the empty set. Let's look at two-line notation. If you have a function written in two-line notation and we want to find the preimage of one element, 1, we find where that element appears in the second row, and we see what elements mapped to 1. So in this case, there's only one element that maps to 1. It's the number 4. On the other hand, if we wanted to find the preimage of the set 3, 5, we would find all places where a 3 or a 5 appears in the second row, and then figure out what are all of the elements above them in the first row. So in this case, it's 1, 2, 3, 5 is the preimage of the set 3, 5. For a graph, we have some set of y values, and we want to figure out which of the x values map to those values. If we're looking for the preimage of 6, we say, well, what is the x values that have 6 as its image? In this case, it's 1. And then if we have a value, for example, 0, that doesn't appear as a function value in this graph, that would say that the preimage of 0 is the empty set. Sometimes we have a closed formula for a function. For example, f of x is equal to x squared. And in that type of case, finding the inverse of that function can be helpful. The inverse function of x squared is plus or minus the square root of x. F inverse of 25 would be the set -5 and +5. F inverse of 8 would be plus or minus the square root of 8, but this function is a function from integers to integers, and so there are no integers that have 8 as their square. And last, here's an example where we want to find the pre-image of a set of numbers, and for that we need to find the pre-image of each of the elements. The only numbers in this set that are the square of an integer are 0, 1, 4, and 9, and the integers that square to give those values are the numbers between -3 and +3. When finding the pre-image of a function that's defined in words, it's important to understand what's happening behind the scenes of this function. So let's consider a function that takes the last letter of an English word. So our domain is the set of all words, the codomain is the set of all letters, and if we were to put as the input the word goat, the output would be the last letter of that word, or the letter T. What is the pre-image of the letter E? That would be the set of all words in W that have E as the last letter. So it's the set of all English words ending in E. What if we wanted to find the pre-image of the set of letters from A up until Y? In that case, we're looking at all words that have as their last letter one of the letters from A until Y. So one way we could write the pre-image of this set is as the set of English words not ending in the letter Z. All right, and that's it for today. See you next time.